Good morning, guys. This is Mr. Leshin. It's good to be back here again. This is one class mathematics and we're week 4. The last time we discussed about geometric construction and we are still on that. We'll continue from where we stopped the last time. So we talked about construction of triangle, the properties by which you consider before you construct a triangle. We discussed that last week. And we discussed about how you can bisect a line segment. You know what line segment is? Drawing the line from one point to another using your ruler or your compass. Yeah, you can get your line segment and how you can bisect it to give you what equal parts on both ends. So we talk about how to construct angle 90. I gave you the properties and we discuss at length on how to construct it and how to bisect angle 90. I told you bisection is cutting into two or splitting, cutting into two to give you what equal half ends. So we bisected angle 90 to give us 45 using angle 90. So we talk about angle 60 also. And we bisected angle 60 to give us 30. So I told you to work more on other angles like angle 135, 15, 120. You just practice more to get a better understanding of the topic discussed. So this week we'll continue again. I will continue with our geometric construction, but in another dimension. So this week we'll be looking at how to construct a quadrilateral polygon. You know what a quadrilateral polygon is. So we talked about how to construct equilateral triangle. So I'll give you all the properties. But before we go into that, I would like to I'll share with you our lesson objective. So this is our lesson objective on the topic. So geometric construction, that's the topic. So this is a lesson objective. At the end of the lesson, students should be able to state the conditions involved in constructing a quadrilateral polygon. You all know what a polygon is. The name of a polygon depends on the size. So when we say quadrilateral, we're talking about fourth size. And there are different types of quadrilateral polygon. We have the square, the rectangle, the trapezium. So we'll discuss more about that. Number 2, how to construct a quadrilateral polygon. I'll give you to the directions, the procedures to follow, and construct an equilateral triangle. You all know what an equilateral triangle is. An equilateral triangle is a triangle that has all sides equal and all internal angles to be equal. That is, the sum of angles in a triangle is 180. So in a equilateral triangle, all the three angles are 60, 60, 60. So that sums up to give you 180. And all the sides are also equal. That's what we call a equilateral triangle. That's a type of triangle. And the last one is find the locus of a moving point. So we discussed locus and some conditions are involved in finding your locus of the points. So let's go to the topic proper. So construction of a quadrilateral polygon. A quadrilateral is a polygon bounded by 4 straight lines. I told you it has 4 sides. It is a mathematical figure with 4 sides. In essence, a quadrilateral will have 4 sides. That's the basic thing about quadrilateral. It has 4 sides. So it includes square, rectangle, parallelogram, rhombus, trapezium, and they have all their properties. The properties of a square is different from that of a rectangle. You all know that in a square, all the sides are equal, and all the angles are 90, 90, 90. The sum of angles in a quadrilateral is 360. We all know that. So in a square, the angles are at right angle, all the sides, while in a rectangle it's different. So what about parallelogram, rhombus? They all have their own properties. So in constructing a quadrilateral polygon, it depends on the information given to know the type of quadrilateral polygon you're constructing. So take these examples of quadrilateral polygons that we have. So this is a trapezium, call it trapezoid. So rectangle, you can say the lengths are the opposite lengths are the same, while the opposite lengths are the same, different from the breadth. So this is isosceles trapezium. That is, we have 2 types of trapezium. The isosceles, that these 2 sides are equal, unlike this one that the sides are not no sides is equal. So a square whereby all the sides are equal, rhombus, parallelogram, and kite. So in constructing a quadrilateral polygon, you need the information on the polygon or the quadrilateral to be constructed. So these takes us to the next slide. Properties of a quadrilateral polygon. These are general properties of them. That is, a quadrilateral has 4 sides, which you have to take very, very important. It is not a triangle of 3 sides. It is not a pentagon of 5 sides. It's a quadrilateral. It has 4 sides. So in construction, we will show you that the sides are 4. So at least a pair of opposite side must be parallel. You know what parallel lines means? Lines that do not means that is at least a pair. That is, 2 of these lines must be parallel. Looking at this, look at all this consider this is a parallel line. This line here with these are parallel to each other. They are parallel to each other. the rectangle, this line here is parallel to this. The square here, this one is parallel. All the two pairs of lines are what? Parallel. So at least a pair of sides must be what? Parallel. At least a pair of opposite sides must be what? Parallel. These are the conditions you consider in your what? In constructing your what? Your collateral parallelogram. If you are constructing and it doesn't fit into these properties, then you know there's an error somewhere. Sometimes opposite sides are what? Or equal. Not most of the times, not in all the collaterals, but some have what? Opposite sides to be what? Equal. Some opposite angles are what? Are supplementary. That is the sum of the angles are what? Equals to what? 180. That's what supplementary angles means. So note, the collateral to be constructed may be any of the following: square, rectangle, parallelogram. They are all what? Types of what? Collateral, as said earlier. They are all what? Collateral polygon includes so square, rectangle, parallelogram, rhombus, trapezium. So you just follow the properties depending on the what figures given or the parameters given. Then you know the type of what parallelogram. Collateral you are what constructing. So we'll go to the next thing. Construction of what? Equilateral triangle. We all know what an equilateral triangle. That is, all sides of a triangle are what? Equal, and the sum of angles in a triangle basically generally is what? 180. So in equilateral triangle, all these angles are equal to what? 60, 60, 60. So let's take the note. An equilateral triangle is a type of triangle in which all the three sides are equal. All the sides of a triangle are what? Equal, and also all the angles are congruent to each other and are each 60. When we say congruent, you know what congruent means? That is in which all the dimensions of the what? A triangle are what? Are the same. They have what? Equal dimension. That is the side, the angle. They have what? Equal what? Dimensions. That's why we say it's what? It's congruent. So these are the properties to consider, or steps to constructing what? An equilateral triangle. Number one, take your ruler. Please follow the step very, very well. Take your ruler and a pencil and construct a segment, a line segment of any length on the paper, label AB. And construct your what? A line segment. Draw, get your pencil and your ruler. You can take 5 centimeters, you can take 10 centimeters, depending on what, how convenient to you. So put the needle of your compass at the end point A, line label AB. The line segment is what? AB. Place the needle of your compass what? At equal radius that's on what? A. Measure the radius of on what? A, point A, and adjust your compass so that the tip of the pencil touches the end point what? B. That is the length of what? AB becomes your what? The radius of your what? Compass. We discussed that in the last class, so you know how to find your radius on the what? Compass and pencil now. So the length between the tip of the compass and the pencil is the what? The radius. So put the needle of your compass at the end point A and adjust your compass so that the tip of your pencil touches the end point B. So put the needle with the same radius, put the needle of your compass with the same radius, put the needle of your compass at B and draw an arc. Draw an arc and put the needle of your compass at B and draw an arc that cuts the arc from what? A. That cuts the arc from what? A. This should be what? A. Put the needle of your compass at A and draw an arc, and also put the needle of your compass at B and draw an arc that cuts the arc from what? A. So draw the line segment from the two endpoints to the point where the two arcs intersect. So let us go into practical how we can what? Construct this what? Triangle. We'll follow the steps one after the what? Other. First thing is said, take a ruler and a pencil and construct the line segment of and label on paper line AB. So this is what we're talking about. This is what? Line AB. Line AB. Place the tip of your compass. Please put the needle of your compass at the point A and adjust so that your what? Compass tip of your pencil touches the end point B. That is the radius by which your compass is now is the length of what? AB. Length what? AB. So place the needle of your compass at A, draw an arc. So if you place the needle of your compass here, you draw an arc. This will be the arc. This arc, you draw an arc. Oh, sorry, you draw an arc like this. So it says again, place with the same radius, place the needle of your compass at B and draw an arc that cuts the arc from A. So if this is the arc from A, so this is your B, place with the same radius, draw an arc that cuts what? The angle or the arc drawn from what? A. So you have this dimension. So it now says, last thing says, draw a segment from the two endpoints to the point where the two arcs intersect. Draw a segment from the two endpoints. That is, draw a line from the two endpoints. That is from point A. Draw a line where the what? Two arcs meet, and draw a line from what? B, where the two arcs what? Meet. So if you measure this length AC will be equal to what? BC and will be equal to what? AB. So measuring the angle You have your 60 here, 60 here, and 60 here to give us this. That this side is equal to what? This side, and it's equal to what? This side, and all the angles are what? 60, 60, 60. So that's how to construct a what? Is how to construct a what? An equilateral triangle. So I'd like you to what? Take note of the what? The procedures very, very well. And with this, you can continue. You can draw your what? Equilateral triangle. So we'll go to the next thing as a locus. So we'll go to our locus. This is like another topic on its own. Locus, but still under construction. So let's say this is a collection of varying position. This is a collection of varying position which describe where an object is what located. It is a set of points that tells the location of a what of an object. The various position must be follow a given condition. In locus, to get your locus, the points, it must follow. We have several conditions under locus, but so in locus, it must follow a given condition. Out of all the what conditions or guiding what the locus of a what point. Look at this now. Locus can be used to describe a distance from a fixed point. That is, it can be like from a fixed point, you find the location, the point of another, but from a fixed point, from a fixed point, equidistance from two given points. You know what equidistance means? That is the end of each side has to be what equal, like your perpendicular, like your 90 degrees or your perpendicular line, whereby you have a line AB and C is the what perpendicular in between them. That is showing that AC will be equal to what BC. That's two equidistance what from two given points. Is different from the first one that says getting the location of a point from another fixed point. Getting the location of a point from another what fixed point. But this one is saying that the location of a point at equal distance from different what end. Equidistance means equal distance from two given what point. Let's say this side is point P or this side is point P. Anywhere in the middle of point P and Q, any location on that point must be what at equidistance from what the point B to what point P and to what point Q. And number 3 says a given distance from what two straight line and so on. There's other conditions like that. But what we'll be considering in this week's topic is the locus of from a constant distance from a fixed point and the equidistance from two given points. One, we consider this how to describe the constant distance from a what fixed point and the equidistance from what two given what points. So in the summary, a locus is a set of all points which locations satisfy or is determined by what a specific work condition. The location of what the locus of a point is what in which the location of that point satisfied or is determined by one of these what conditions stated out above. So we take the two conditions. That's what we'll be discussing in this week's topic. So look at this now. The locus of a point at a given distance from another what fixed point. The locus of a point at a given distance from another fixed point. And like I said earlier, that the conditions we'll be considering is what locus can be used to describe the constant distance from a what fixed point, a constant distance from a what a fixed point. So the locus of a point at a given distance from another fixed point. When we say fixed, it's constant, it's steady, it's not moving. It's not what moving, but the distance will be considered with what is the location of the point, but at that same what distance, at that same what distance from the what fixed point. Excuse me. The locus is a circle. The locus is a circle. The locus of this point of a given distance from another fixed point is a circle where radius R, where radius D is the given distance, and the center is the what given fixed point. Here now look at this diagram very well. This is what the center. This is what the center is the center, and it's labeled what P. While Q is the what at the location of what of the locus at a distance what D, which is what now forms what the radius. What the radius. Look at this point now. Q can be also at this point here. All these points tick around at the what the locus of the what of the point from this what fixed point, but at what equal what radius. That's why I say the locus of a point at a given distance from another what fixed point. This is the fixed point. This Q here of this dash here can be here, can be here, can be here, can be here, all around, can be anywhere in this circle. But it is from what from a fixed point at a what given what distance. That is what this is talking about. At a what given distance. Take this example. Given a line PQ. Let's say this is a line PQ. Is a what line segment, and the Q is what the locus of the point we are considering. Require locus of point which is what 3 centimeters from what P. That is anywhere around this circle. The distance between P and Q is what 3 centimeters, which now forms what the radius. So now say construction, how to construct it is what? Draw a circle, center P, and radius what? 3 centimeter all through. 3 centimeter what? All through. 3 centimeter what? All through. So it now analyzes it. Look at this example. The locus of the point is the path traced out. You see, it is the path traced out by the point as moved through 2D or 3D space. In Loci, problems you have to find the path or a given rules. Let's take the example. The locus of a point that moves so that it remains at a what? Constant distance from a what? Fixed point. Look at this now. It remains at a what? Constant distance. Constant what? Fixed point P. And every point, all these dots here you see are the what? Are the locus of the what? The new point. But at a what? Given distance. The measurement from P down to this point here must be the same measurement from P down to this point here. So it is at a what? Given distance, but what? From a what? From a what? Fixed point. The locus of this point is from a fixed point at a what? Given what? Distance. Look at this. Draw the locus of a point that moves so that it is always 4 centimeters from the what? From the fixed point. It is always 4 centimeters from the what? Fixed point. So this is P and you're constructing it. This is the distance 4 centimeter measure with your what? Ruler or with your compass using a radius of 4 centimeters. So any point on this circle is what? Is the locus of the what? Of the new point we are looking at. And it has from the what? From the fixed point to what? P at a distance 4 centimeters. Another example to explain it is if you look at your wall clock at home, the fixed point is the center of the clock that moves that the seconds or the hour hand moves at what? 1, 2, 3. Look at the distance from the center of your clock. Measure the distance to 1, to 2, to 3, to 4. Your one label 1, 2, 3 are the locus of the point. But at a what? From the fixed point, which is from the center of the clock, at a what? Given distance, if you measure the distance from the what? From the center of the clock to the what? To 1, to 2, to 3, you see that it is the same what? Distance. So that is the locus of a what? Of a point. The locus of a what? Of point at a given distance from another what? Fixed point. Take note, it's what? The location of all these dots are the what? The locus of the new point. But from a what? A given what? Fixed point. From a what? Fixed point at a given what? At a given distance. Which the distance is the what? Is the what? Radius of the what? Of the circle. So look at the next one, which is what? The locus of points, which is equidistance from two given points, which is what? Equidistance from two given points. Let us go through the notes. It says, the locus required here is a perpendicular bisector. We all know what perpendicular means, a 90-degree. Bisector is to what? To cut into two. Bisecting is what? Cut into two. So the locus required here is the perpendicular bisector of the line joining two points together. Of the line joining two what? Points together. Now, look at it now. You know how to draw your angle, construct your what? 90-degree. I told you in the last class, and it is what we did in the what? Construction. So you look at it now, given 2 points PQ. Given 2 points PQ, this is what? Point P and Q. The locus of the points equidistance from P and Q. So construction, construct the perpendicular bisector. How do you construct the perpendicular bisector? Get your what? Is like how we constructed the 90 degrees. Sorry, the equilateral triangle. Construct your what? Angle 90 degrees from what? PQ. Place your compass at equal radius on P. Measure it to be what? At the same length to PQ. So place it here, draw an arc, and put the tip of the compass at here again. Draw an arc up and what? Down below. Draw the line. So this forms the what? The bisector. This is what? A 90-degree angle. If you measure it now, you see it's what? 90-degree angle. So the locus required is the perpendicular bisector of the line joining what? 2 points together. What I mean is that, look at this. If we label this place, let's say we label here as O. OP is equal to what? OQ. So the point, and let's label the point, let's say here is M. Here is what? M. So the point OP is equal to what? PQ. And here is O, and here is M. MO is the what? Perpendicular bisector. That is, MO is what? Perpendicular what? Bisector. That is, any point on OP, MO, any point on OMO must be equal to the what? Must be equal to the what? Distance from P and equal to the distance from what? Q. That's what we are talking about here. That is, the locus required there is the perpendicular bisector of the line joining what? 2 points together. That is the locus of point, which is equidistance from two given points. That is, the point, any point on this line, the bisector, must be equal to the distance of this point to P and must be equal to the distance from what? The point to what? To Q. Any point on this bisector at all. It could be the top, must be equal to this. It could be in between here, but any point on the bisector must be equal to the distance of what? One end and must be equal to the distance of the what? Other end. So that is what the locus of what point, which equals equidistance from two given points, is what talking about. Let me take you through the one example on that. Look at this diagram very, very well. So after constructing, this is the line AB, and this is the bisector. This point here at the bisect is the what forms the what the bisector. All these dotted points here forms the what the bisector, the 90-degree, the perpendicular line, which cuts the what line segment AB. You can see this side 1 to 3 label shows that what they are equal what of length. If this is labeled the point, that is from A to here is what equal to A, from this point to what B. So on this bisector line, you can see that any point on the bisector must be equal, must be at the same what equal distance from what from this point to point A of the other end, and must be equal to the what same point on the what other end. You can see it's labeled is indicated as two lines and two lines showing that they are what equal what distance. And any point at all, that's why I said look at this one from here also down here must be equal to the distance from this point down here, because it's on the what on the perpendicular what bisector. You can see this another example again from this point. This is another point on the what bisector is at equal length to A and also at equal length to what to B. So this is the locus of point which is equidistance from what from two given points. With this explanation, you were able to what construct your locus either from what from a fixed point or of point which is what equidistance of what two given points. I would like you to practice the equilateral triangle and the quadrilateral polygon. So we've come to the end of this week's topic. We sent questions. I sent questions earlier on their online notes, and I believe with this explanation you can solve and construct all locus and equilateral triangle and any quadrilateral polygon you want to construct. Thank you very much, and have a wonderful time at home.